Welcome to the second part of this introduction to Particleworks from zero to hero. And today we will have a look at the post-processing that is available in Particleworks. All in one graphic user interface. We will see the most important, let's say, post-processing operation you would like to do on your model using this example, that is the gearbox from Comer example that we ran in the previous section, in the previous video. So as you can see, we collect some results up to 47 frames because we decided to save every 0.01 second. And we can see the transient at of the initialization of the simulation. And we can also visualize the velocity field on the fluid. So as you can see, the fill here is the fluid, and if we go to the properties, we have the average velocity, the max velocity, and what we can do, for instance, is to create a profile just to enable us to visualize what is happening inside the gearbox. So if we do something like this, we can indeed inspect what is happening inside the gearbox with a nice visualization, and we can see the splashing on top and some particles sticking to the gear. For the purpose of this demonstration, we are using a quite big particle size, so it's not capturing all the splashing phenomena, but in general you get the idea. Okay, so let's say I want to also understand what is the churning losses or the resistive torque due to oil on a specific element. For instance, this element, the shaft in, I could go to the corresponding geometrical result, and I can show load result torque. I can do the torque total in the direction of Z, because that will be our resistive direction. And as you can see, after the transient, we achieve a certain level of resistance, or a certain torque, resistive torque, approximately 0.5 Newton meter. And in this way, we can estimate, given the RPM condition, what are the losses due to oil only on that specific element. Okay, so let's also say I want to analyze what are the wetted surfaces in on the housing, in the inner side of the housing, just to understand where the fluid ends up or doesn't end up. Okay, so what I can do is to launch one of the post-processing that we have available in Particleworks. They are all packaged inside the same GUI, and by doing a mapping on, let's say, the last 20 frame or so, let's say, let's pick some frames, I can map the number density that is connected with the amount of oil in a given region, and basically selecting the housing STL, so the surface of the housing, I can do an average over that period, so over 0.4 seconds, something like that, or 0.3 seconds actually. And I could, just do and launch the average. Okay, so now the system will look at all the frames, the 30 so frames, okay, and it will output the average wetted surfaces on the housing. So let's just wait a second so that the post-processing runs. While we wait, we can also take a look at the amount of oil in a given region by using the probe post-processing tool. This is also another important post-processing. So basically, we can have a look maybe at the amount of oil splashed above a certain level. We could then create a new region, a probe region. It's a very small probe region there, but if we go like 50, 50 and 50 millimeter, we can start to see it. So basically, by activating the gizmo, I can drag this around and I can position it and expand it maybe. Okay, so in this way, I could monitor the amount of oil above a certain level, let's say above yeah, the output gear middle lane. Okay, so in this way, I will be able to monitor that that amount of oil, but I could also generate an STL or a box covering the bearings here and estimate in the same way the volume reaching, the amount of oil reaching that region. Okay, so for now, let's just launch a basic example like that one, and it will run together with the other post-processing that is almost done. So while we wait for the probe post-processing with that probe region, we can have a look at the map that will be generated in seconds. I will disable the profile for now, and I will also hide the fill. As you saw, the post-processing of the mapping finished, so we can move the color map to the number density. That is what we were mentioning before, so it's connected with the wetted areas. Okay, so actually I could re-enable the profile so I can see what is going on inside, and exactly we can see that we have information about the wetted areas. I will try to get a better look at it by just maybe showing only the mapped values. So in this way, you can see the film formation, the average film formation in the regions inside the casing. So of course, this was not a stabilized solution, but you get the idea. And I could repeat the same mapping to get the wetted surfaces on the gear or on the bearings as well. So to finish, let's take a look at the post-processing probe that we were able to launch. So in the directory here, you have a CSV file collecting all the information, like the average velocity or pressure or the amount of oil in the region that we just discussed, so this one here. And if I now right-click here and show probe plot, I can select the fill, and I can get the number of particles in that region. Okay, so it's connected with the amount of oil, and I will see exactly that after 0.2 seconds, basically the amount of particles, so the volume in the region above a certain level has reached a stability. Okay, so this can also help me in understanding if a simulation stabilized with respect to the flow distribution. Okay, so this is a very basic introduction to the post-processing you could do and achieve on a gearbox test case. You can do something very similar to this map, also accounting for heat transfer coefficient or pressure in other systems like maybe e-motors or actually also gaskets. In this case, we could have a gasket and we could want to have a look at the pressure on that gasket. So really a lot of possibilities here, a lot of post-processing that will be covered in the full training on Particleworks. And as you can see, in one interface, we have simulation control, input, output, and visualization of results. So thank you for listening to me and for your interest in this demo, and looking forward to connect with you on LinkedIn and get to know each other also via email.